Hello again. In this video, we want to look at destructive testing. Sounds a bit ominous and sudden, and usually it is actually. So let's have a discussion about how it all works. So when we perform destructive testing, we're actually testing. Maybe I could move over to the left. We're going to test until there's a failure in the specimen. Okay, so something snaps or breaks or ceases to function anymore. We are then able, because we start off with a small stress or load, and we work all the way to the absolute maximum until the thing snaps or breaks, then we do actually have data for a range of loads. Okay, so we have data for range of loads or stresses, if you want to call them that. Okay. And for that reason, we have more information about the specimen, the test piece, in other words, than non-destructive testing provides. Although usually a combination of both can be quite intriguing in terms of the data yielded. And destructive testing is actually a bit more suited to mass-produced items. So the cost means we are here more suited to mass-produced items. Okay, so for example, we think, so if a factory produces 1,000,000 children's robots per year, then that would be a good candidate, one of those or a few of those for destructive testing. If a factory produced 3 or 4 20 million pounds sports cars per year, then you would not go down the route of destructive testing in those, certainly not. Okay. What sort of monitoring equipment might we use? Okay, monitoring equipment. Okay, so very often you will see a high-speed camera being used. That way we can actually see a specimen break apart, snap, fracture, wherever it might be. Also, for that reason or other reasons, we can use a sound detector, or we can use a nice simple stress gauge. Okay, these are common used in destructive testing. What about types of destructive testing? Okay, maybe I could fit them all into one page here without scrolling. So types, we have crash test. It's probably the one you're familiar with most. Crash test dummy. Okay, so the dummy in the car. We can have a stress test. Stress test is basically you deliberately deform a specimen and see perhaps how it reacts. Maybe it would spring back to its normal shape. Who knows? We can do pollution or corrosion test. Okay, so how's the thing going to behave when it's within the environments it's designed for? It could be designed to be in acidic environment, so therefore we're going to possibly use a long period of exposure to the acid or the corrosive environments, etc., and keep it going non-stop until the item fails, because this is still destructive testing. Okay, we can test for temperature tolerance, so an oven test. We can do a humidity test. And again, we are basically controlling the humidity until we have failure, controlling the temperature above until we have failure, etc. We can do the same thing with pressure. Every device or material has limits in terms of which pressure it can withstand. A couple more I can think of. There's possibly a vibration test. Quite often specimens or items are placed on a tray, and the tray is basically vibrated really violently forever until the components break. Maybe there's an electrical connection to them or whatever it might be, but you vibrate them until they break. And there's lots of data that can be had from those analyses. Finally, well, yes, there's always software testing. This is a little bit different because we're actually testing a program. We're actually going to test the program until it does not run anymore. Okay, so we put lots of stresses on the software in terms of data, inputs, outputs, processing, post-processing, lots of different factors. All software, all pieces of software are going to fail at some stage, depending on what you do with them, what the inputs are, and how many outputs you're stressing the software with. Potentially also the specification, what you expect from the software. Okay, so there's a sort of quick chat about destructive testing, quite an interesting area, and it can be used quite effectively with non-destructive testing, which is the subject of the next video. So hopefully that's been useful for you. Thanks for watching. See you next time.